Resource allocation graph. Resource allocation graph is the most efficient and convenient way to represent the state of the system. Means in our system, like how the resources are allocated to the processes and how the processes have been assigned the multiple resources. To represent that, we use the resource allocation graph, that is also known as RAG. Means अगर हमारे system में, in our system, whether there is a deadlock or not, to represent that, it is the most suitable method. That is the RAG, that is resource allocation graph. Like a normal graph, it is also having two things. One is a vertex, one is a edge. Means every graph has two things, edge and vertices. So in the vertices, there are two types of vertices, process vertex and resource vertex. Means whatever the number of processes in our system, मतलब जितने भी processes they are running in our system, all the processes are represented with the vertex and they are generally represented with the circle. And resource means whatever the resources like CPU, register, memory, monitor, printer, whatever the resources we have in our system, like in our laptop, mobile, or like a tab. So all the resources are represented again with the vertex, but we represent in a rectangle kind of. And resources are of two types. One is a single instance, one is a multiple instance. Means in our system there can be a resource which is only one, means that is present only single, like a CPU monitor. हमारे सिस्टम में CPU monitor generally आजकल हमारे सिस्टम में we are having the dual core quad core system, but if we talk generally then we can say कि in our system we have one CPU, one monitor kind of, but some of the resources are which is multiply present, means they are in multiple numbers, that is we can say register. And like we can have more than one printer which is connected with our system, so that can be a multiple instance. You don't need to cram it, this is a normal thing कि like multiple and single instance resources. And edges, what they represent? Edges represent two things. One is a assigned edge, one is a request edge. Assigned edge means like we are having a resource is connected with the process, and if there is an edge which is moving towards the process, if there is a edge which is moving towards the process, it means that resource is assigned to a process. Means वो वाला जो process है that has already taken that resource. And request edge, how we represent it? If the arrow is going towards the resource, means from the process it is going towards the resource. R means resource, P means process, then we call it a request edge. Means यहाँ पे P is requesting for a resource and यहाँ पे P has already taken a resource R. This is how we represent in a normal RAG. Let's solve one example. Like we are having two processes P1 and P2. We represent the processes in the circle and we represent the resources in the rectangle. Both are vertex, but we are having the single instance. This example is of single instance, means we are taking a resource of single instance, means only one instance is there. मतलब R1 का भी एक instance है and we are having only one instance of R2. We can say like R1 is a CPU and R2 can be a monitor. That is the simple meaning. So P1 here, what it represent? It represent P1 has taken, means assigned. P1 has taken R1, P1 has already taken R1, but it is request for the R2 because edge is moving towards the resource. It means it is requesting. And here P2 has taken R2 because edge is moving from the resource towards the process. It means R2 has already assigned to P2 and there is one more edge from P2 to R1. It means P2 needs R1. P2 request for R1. This is how we represent the RAG, normal RAG. But here we have already assumed that this is a single instance, means only one R1 instance is there, only one R2 instance is there. Now, what is the advantage of this? Means why we represent like that? The main reason is we have to check कि whether in this system there is deadlock or not. This is the mostly asked question in the GATE and other competitive exams, जहाँ पे आपको एक RAG, we will be given a RAG, and by using that RAG, by looking at that RAG, you have to tell कि whether their deadlock exists or not. That is only the question which is asked most of the time. So let's examine this one first. Let's say कि we have one R1 and R1 is taken by P1, P1 is requesting for R2, R2 is taken by P2 and P2 is requesting for R1. This is what? A kind of circular weight. Circular weight. And circular weight is one of the necessary conditions for the deadlock. Means in your system there must be a circular weight if you want in your system a deadlock. So yes, there is a circular weight. There is a circular weight. There is a circle. Circle means like a loop. Means if we start our journey from R1, can we come back to R1? Yes, we can come back to R1. That is called a cycle. So can we say if there is a cycle in the RAG, then there will be a deadlock? Can we say if there is a cycle in a RAG, then there will be a deadlock? So let's examine this. Here we can solve it normal also by looking at the graph. We can easily say there is only one resource of R1, only one instance of R1 which is taken by P1. But P1 needs one more resource, that is R2. So can we say कि P1 will get execute? No. Why P1 will not get execute? Because P1 says I am having R1 but I need R2 to get execute. P1 has taken one resource and waiting for the another resource. So hold and wait is also there. Here is hold and wait. It is holding R1 waiting for R2. And on the same time P2 has taken R2 and waiting for R1. P2 is saying, can I say that P2 will get execute? No, P2 will also get not execute because P2 has taken R2, but to get execute P2 needs R1. But how P2 will get R1? No, because R1 is already taken by P1. And how P1 will get R2? No, because R2 is already taken by P2. So means both the processes are waiting on happening of some event. What is the event? P1 is wishing that if I get R2, I will get execute. But his wish will not get successful because R2 has already taken by P2. And P2 is also wishing that if I get R1, I will get execute. But how he will get R1? Because R1 is already taken by P1. So both are waiting for one resource. And who will fulfill that request? Nobody will fulfill. So that will be a deadlock situation because nobody is going to fulfill their request. So that is called a deadlock situation. So it is a simple graph, so we can easily say that there is a deadlock. But there is another method which is definitely giving you the guarantee whether there is a deadlock or not, and you should follow that method, because if the graph will become complex, we will see some more example. If the graph will become complex, then it will be very difficult to analyze manually by looking at the graph. So what is another method? Let's examine that. So let's say how many processes we have? 2. In this diagram, how many processes we have? 2. P1, P2. How many processes we have? 2. That is P1 and P2. P1 let's make the diagram. Allocate and request. Circular weight is there. Let's remove this so you can clearly get the diagram. So 2 processes are there, P1 and P2, and you just write a allocate and request. What is the allocate and request? Resources. So let's say how many resources we have? 2, R1 and R2. R1 and R2. So by looking at the graph, allocate means already holding that, already getting. So whether which resource P1 holding, already allocating, R1, means P1 is already having the R1 and P2 is already having the R2 because P2 has already taken the R2. So just write 1 1. 1 1 means P1 has taken R1, P2 has taken R2. So whatever the allocation is there, allocation ko we write 1. Then we write the request for the same resource, that is R1 and R2. So P1 is requesting for R2. You can clearly see P1 is requesting for R2. So P1 is requesting for R2. So R2 mein we can write 1. P1 is not requesting for R1, so we can write 0. P2 is requesting for P2. P2 is requesting for R1. So P2 is requesting for R1. So just write 1 1 1. And P2 is not requesting for R2 because it is already holding that. So just write 0 on that. Now after filling this information, now you need to check the availability. This is same like the banker's algorithm. I am just applying the banker's algorithm. For more detail, you can just refer to my that video of banker's algorithm. So you will get the more knowledge. So availability, otherwise you can follow that also. Availability means how many we have currently available. Currently मेरे पास कितने available हैं? So R1, is there any resource of R1 available? No, only one was there, which is taken by P1. So 0. R2, do I have any resource of R2? No, so it is already 0. So means मेरे पास R1 and R2 both are 0 0. Currently I am having R1 0, R2 0. Now by looking at this availability, you need to check कि can I fulfill the request? Can I fulfill the request of P1 or P2? What is the request of P1? 0 1. Means 0 resource of R1 needed, but 1 resource of R2. Can you give? No, we can't give because we have 0 0 available. We don't have even a single resource of R1 and R2. Both are nil. So currently availability is 0, means I am not having any resource with me. Then how I can fulfill the request? I cannot fulfill the request of P1. Can I fulfill the request of P2? No. I cannot fulfill the request of P2 because P2 needs 1 resource of R1. Do I have? No. So means neither I can fulfill the request of P1 nor I can fulfill the request of P2 because my current availability is 0. So in that situation, you can clearly say there is a deadlock situation. So as we have already calculated, but now this is a foolproof method kind of, which will definitely give the right answer in all the cases. So you can clearly say there is a deadlock in this system. So is RAG mein there is a deadlock. So this is how we represent. But again, this example is of single instance. So let's solve one more. Let's solve the second question. I'm just making the diagram over there, this table. Let's say how many processes we have. P1, P2, P3. Again write the allocation and request. Allocation and request. Visible? Allocation and request. So here how many resources I have? R1 and R2. R1, R2. R1, R2. This is the diagram. Means we are now examining this RAG. So just write down all the processes at this time. All the processes यहाँ पे लिख दो and allocate and request and all the resources. How many resources? R1, R2. So R1, R2, R1. Now allocate. P1. Let's say P1. P1 has allocated any resource? P1. Check. Yes. P1 already having R1. One instance of R1 is taken by P1 because if the edge is going towards the process, it means it has that resource. So means इस process के पास already that resource is present. So P1 is having R1. Any other resource, whether P1 is having R2? No. So just write 0. Check P2 is having which resource? P2 is having R2, because edge is moving towards the process. It means R2 is already taken by P2. So R2 is already taken by P2. So just write 1, and R1 is not taken by P2. So just write 0. Check. P3 has taken any resource? P3, no. There is no edge moving towards the process. So neither P3 has taken R1 nor R2. Any instance has not taken by P3. Now check the request of P1. Whether P1 is requesting? No. P1 is not requesting for any resource. If it is not requesting, simply write 0, 0. Check for P2. Whether P2 is requesting for any resource? No. P2 is also not requesting any of the resource, because there is no edge moving from P1 towards any resource. Nahi hai. That is moving toward the P2. So P3. Check whether P3 is requesting? Yes. Here P3 is requesting one resource of R1, one of R2. See this one. P1 is requesting that one of R1. So means we have to write 1, 1. Now check the availability. Check the availability. Check the availability. Do I have any resource of R1 available? No. Because only one instance which is already taken. Do I have any resource of R2? No. Only one instance already taken by some process. So how many availability? 0. But by using that availability, can I fulfill the request? Yeah. P1 is requesting nothing. So if it is not requesting anything, it will get executed. Because P1 is having R1 and P1 is not saying कि I need something. If it is not saying I need something, it will simply execute. And when it get execute, it will terminate. We call it terminate. So when the termination is done, then what will happen? All the resources will be taken back. So when the P1 will get terminated, so we write here, P1 will get terminated. So whatever the resources of P1, they will be taken back. So 1, 0 means 1, 0. Now the new availability will be 1, 0 means 1 of R1 I have now and 0 of R2 I have. This is what the new availability here. Now see, can I fulfill the request of P3 now? No, still it is not possible, because I can give one resource of R1 to P3, but P3 needs one resource of R2 also, but I don't have any. But can I fulfill the request of P2? Yes, P2 needs nothing. P2 is having one resource R2 and it is not demanding anything. If it is not demanding, simply terminate. It will get terminate because it will get successfully execute. So when it get terminate, I am just writing here, if it get terminate means whatever the resources it is having, they will be taken back. So जब ये taken back हो गया, then we can simply say what is the new availability? 1, 1. Because whatever the resources which are taken by P2, they will be taken back and added to the, it will be added to the current availability. तो what was the availability? 1, 0. उसमें add कर दिया. I am having 1, 0. What is the P2 allocation? 0, 1. So when I add this, so it becomes 1, 1. So what is the current availability now? 1, 1. And how many resources I have? Both are having 1, 1 resources. And how many processes? P1 already terminated, P2 already now check for P3. P3 need is 1, 1. Can I fulfill? Yes, I am having 1, 1. So I can easily fulfill the request of P3 because P3 needs one instance of R1, one instance of R1 and one instance of R2, and I am having one instance of R1 and R2 both. So मेरी availability है, I will give that to the P3. So P3 will get successfully terminate and it will move out from the system. So this is how we can execute all the processes. Now in this case, in this diagram, can we say there is a deadlock? No, there is no deadlock. Deadlock means all are waiting for happening of some event, but that event is not happening. But here the event is happening. P1 is not waiting permanently, like infinitely. There is a difference between the two terms. Like we say waiting, we are simply saying कि a process is waiting. A process is waiting for resource. If the waiting is finite, if the waiting is finite, means I know कि a process will wait for that particular amount of time. The time can be 1 minute, 1 hour, 1 day, 1 year, 10 years, 100 years. Even if it is 1000 years, still it is finite. So that is called the starvation. And if the waiting is infinite, means I don't know what is the amount of time a process will wait to get executed. That is infinite. So that is called the deadlock. That is called the deadlock. This is the very important part. If it is finite, we call it starvation. And in finite, we can simply say, if anybody says a process is waiting for this many years, no problem. This is still a finite value, because we know that after this amount of time, the process will definitely terminate. But infinite means totally. So this is the case of starvation and this is the case of deadlock. So in this case mein there is no starvation, there is a deadlock, because P1 and P2 will be waiting infinitely. But here in this, P1 is not waiting. P1 will simply get execute because it is demanding nothing. P2 will simply get execute because it is demanding nothing. But P3 will wait for some time, because P3 needs 1 when it will get 1 after P1 and P2 will get execute, and P1 will and P2 will get execute after some time. That amount of time is finite. So P3 को पता है, P3 knows कि after some amount of time I will definitely get execute. So this is finite waiting, and finite waiting is always starvation. But here the question will be asked simply whether it contains the deadlock or not. So there is no deadlock. There is no deadlock. So this is how we can examine the questions on the RAG. One last point, that is, here we have seen circular wait, means there is a cycle. There is a cycle. Whether there is a cycle, if I start my journey from P1, can I come back to P1? No, even I can't move anywhere. Let's start from P3. Can I come back to P3? Let's say P3 to R1, R1 to P1. There is no way I can come back to P3. So I can say it is acyclic. Means there is no cycle in this. There is no circular wait. There is a circular wait. So if there is a circular wait, if there is a circular wait in RAG, if RAG has circular wait, means a cycle, then always there will be a deadlock. If RAG has a circular wait, that is a cycle, there will be always a deadlock. This is true. This is true. But only in the case if there is a single instance resource. That is the important point. That is very important point. If there is a single instance resource, means every resource is of single instance and there is a circular wait, means there is a cycle, then there will be always deadlock. Yes. And if there is a single instance and there is no circular weight, there will be no deadlock. Yes, means iska vice versa bhi true hai, but only for a single instance. Means just for a single instance. I am talking about the single instance only. In the single instance, if RAG has a cycle, then there will be always deadlock. True. And if RAG has no cycle, then no deadlock. Yes, this is also true. So both the statements are true, but only in the case of single instance, because abhi tak I haven't discussed about the multiple instance. Multiple instance we will be talking in the next video. So in the single instance, if there is a RAG and it contains a cycle like this, there will be always a deadlock. And if the RAG is not containing any cycle but in a single instance, then there will be no deadlock. That is also true. So these 2 points are very important in this. So this is all about the RAG with a single instance. So if you like the video, please share it with your friends and colleagues, and please subscribe my channel. Thank you.